All right. Hey, Algebra 2s. Here we are with your warm-up problems. Let's see how you did with them. Graph the following functions. Clearly mark at least 3 to 5 points per graph and identify the properties. Round to 2 decimal places if needed. All right, so I have a square root graph, so I know it's going to be an eyebrow. How about that? When I have a second degree, I know that I'm missing the tail. My starting point is going to be from my transformations. So when I look, I have no horizontal shift, but I have a vertical shift of 2 up, which means my starting point, I don't move left or right, but I do go up 2. So we're going to have our starting point be right there. When I talk about my domain and my range, that's going to really depend on my graph. And I want to get my graphing calculator out so that we can see where this graph stops and starts. If I know that nothing in my graph is going to be to this side, my domain is going to start with that 0 and end at positive infinity. My range is going to continue going up like this. So you know that 2 is the smallest element of my range. Positive infinity is my largest. Our y-intercept is given to us because I know that 0 as an input is going to give me 2 as an output. This graph is never going to hit the y or the x-axis, so there are no zeros. It is increasing from the minute that it starts at an x value of 0 all the way up to infinity, and it is never decreasing. Yes, it is a function. Yes, it's one-to-one. And yes, it is continuous. We do have one local minimum, and that is going to be the smallest point is at over 0 up 2. As x approaches positive infinity, so does y. So when we look at graphing this equation, we can go ahead and take a look at 2 is going to be my stretch. Make sure I add that in here. A stretch of 2. The square root of x, close my parentheses, plus 2. When I look at the graph, I can see it goes up and it has a taller output, twice as big. When I go to my table of values, I can see 0, 2, and then my next point over 0 or over 1 up 4. And then over 4 up 6, and then over 9 up 8. So I can see this graph grows like that. All right, let's take a look at number 2. When we look at the difference between 1 and 2, I have to look at my index. And my index shows me that this one is going to be a cube root. So we talked about the square root being an eyebrow, and this one will be a snake. So when I look at these transformations, I don't have any stretches or compressions, and I don't have any reflections. My center point is going to be, remember this is naturally negative, so it's going to move 1 in a positive direction and down 5. So if I look at my graph, 1 in a positive direction and down 1, 2, 3, 4, 5 puts my center point right there. My graph is shifted to the right 1, and it is shifted down 5. My domain for a cube graph is going to be all real numbers, and my range is going to be also all real numbers. When we start looking at where the y-intercept or where it hits the 0, we can go ahead and graph it. So we'll go ahead and clear out our other one, and we'll put in our cube root. We go to the math menu, and we take the cube root of x minus 1 and close the parentheses, and then that minus 5 is outside of the parentheses. When I look at my table or my graph, there I can see my snake down at the bottom. And I can go ahead to the table of values, and I can look at, I knew that over 0 down 6, here's my 1, -5, and then my 2, -4. So I can look at my cube graph having this kind of curve. So when we look at where it hits the y-axis, my y-intercept over 0 down 6, that's easy. When we look at what x value gives us an output of 0, that one's a little harder. And in fact, that's today's lesson. We're going to be talking about how to solve these equations, because if I had the cube root of x minus 1 minus 5, if I set that equal to 0, I need a strategy for how to solve this. For now, I'm kind of at the mercy of my table of values. So I know that as I scroll down my table, my output is getting closer and closer and closer to 0. So I can keep scrolling and keep scrolling and keep scrolling and recognize that it's going to take a long time, but eventually it's going to get all the way up to 0. Now, if you don't want to do this, that's fine. Just hang on and wait until mine gets to 0. I'll share my answer. I'll share my answer with you. All right, so guess what? It finally is going to hit that x-axis at, do you see it down here? 126. So 126 is going to be my 0. We're going to talk about how we go ahead and do this. We might come back and visit it after today's lesson. All right, let's look at our increasing interval. Guess what? This graph is always increasing. So from negative infinity to positive infinity. My decreasing interval, there's none or never. It doesn't decrease. Yes, it's a function. Yes, it's 1-to-1. And yes, it's continuous. There are no local minimums and maximums. It continues going on in both directions forever. As x approaches negative infinity, guess what? So does y. As x approaches positive infinity, guess what? So does y. All right, so here's your deal today. You're going to, you've already completed the warm-up, and you've already checked your warm-up with the key. Go ahead and log on and take a look at 5.5 with the key. And remember to ask questions. So anything you don't understand, make sure you ask. This is going to be an important part of your work while I'm gone. We learn from the mistakes that we make. So please reflect on your missed problems and make some notes so that you don't make those mistakes again. You're going to have a lesson with the video, and then you and a partner are going to check in and do a Sage and Scribe activity together. All right, to do a good job, pay attention.